Welcome to Daily Papers, the podcast where we break down cutting-edge research into a conversation you can actually follow. Today, we're talking about an AI that became a champion hacker.
Well, a champion ethical hacker. The paper is STRIATUM-CTF, a protocol-driven agentic framework for general-purpose CTF solving. And it's about teaching an AI to be incredibly good at finding security vulnerabilities.
Right. So to start, let's talk about what that job is actually like for a human. Offensive cybersecurity, or what's sometimes called penetration testing, is a really complex manual process.
Exactly. Imagine you're a detective trying to find a way into a secure building. You have all these specialized tools, one to check for open windows, one to analyze the locks, another to check the blueprints. But you, the human, have to be the glue. You take the information from one tool and decide what to do with the next one. It's slow, it's complicated, and you're bound to make mistakes or miss something.
So the obvious thought is, let's get an AI to do it. We have these large language models, or LLMs, like the ones that power ChatGPT. They're great with code and text, so they should be perfect for the job, right?
You'd think so, but early attempts were clumsy. They either acted like co-pilots that constantly needed a human to tell them what to do, or they were naive agents that would just try to type commands directly.
And that's where the big problem of hallucination comes in. The AI would literally just make things up. It would invent commands that don't exist, or try to access files that aren't there. It's like telling a robot to bake a cake and it invents a new ingredient called flouronium. It just doesn't work.
Another issue they found is called context drift. On long, multi-step tasks, the AI would essentially forget what it was doing. It's like walking into a room and forgetting why you went in there. Information it discovered in step 1 would be lost by step 20.
This is where today's paper comes in with a really clever solution called STRIATUM-CTF. The core idea is to treat the AI like a brilliant but slightly chaotic new employee. You don't just give them the keys to the kingdom and hope for the best. You give them a very specific process to follow.
They built a 3-layer system. You can think of it as the brain, the manager, and the hands.
Okay, I like that. So what's the brain?
The brain is the large language model itself, in this case one called Claude Sonnet. It's the creative part. It does the high-level planning and strategizing, thinking things like, okay, I see a web server. I should probably scan it to see what services are running.
And it passes that plan to the manager.
Exactly. The manager is what the paper calls the protocol layer. This is the real innovation. The brain isn't allowed to just type a command. It has to fill out a strict, formal request, almost like a digital form. The form might say, action, scan server, target IP address, fill in, tool to use, select from dropdown.
So no made-up tools allowed.
None. The manager checks this form. If the brain tries to use a tool that doesn't exist or formats the IP address incorrectly, the request is immediately rejected. The paper calls this layer a circuit breaker for hallucinations. It forces the AI to stay grounded in what's actually possible.
So once the manager approves the request, it goes to the hands.
Yep, the hands are the execution layer. This is where the real cybersecurity tools are kept. It runs the validated command from the manager, and then, crucially, sends the results back in a clean, structured format, like a spreadsheet, not just a messy wall of text.
So the AI gets feedback it can easily understand, which helps it plan its next move without getting confused. It's a continuous loop. The brain plans, the manager validates, the hands execute, and the results feed back into the brain's next plan.
That's the loop. This strict protocol prevents the AI from going off the rails. It can't hallucinate commands, and it can't forget what it's doing because the state of its world is constantly being updated by real, verified feedback from its tools.
All right. The big question, does it actually work?
Oh, it works. And they proved it in the most impressive way possible. They didn't just run it on some old static benchmarks. They entered their AI into a live capture the flag competitive.
For listeners who don't know, a Capture the Flag, or CTF, is basically a hacking Olympics. Teams of students and cybersecurity professionals compete to break into custom-built computer systems and find hidden flags.
And the AI, competing under the team name Graveyard, got first place. It beat 21 other teams, all composed of humans.
Wow, first place against humans in a live competition? How did it have an edge?
Speed and consistency. The paper notes that a task that might take a human 30 to 60 seconds of carefully typing commands and parsing the output, the AI could do in under a second. And when an attack failed, the AI didn't get frustrated or start guessing wildly. It just systematically, methodically tried the next logical variation until something worked. It has no cognitive fatigue.
So what does all this mean? Are we building Skynet?
Not quite. The real goal here is to build incredibly powerful tools for defensive cybersecurity. Imagine an AI like this working for a company 24/7, tirelessly and systematically testing the company's network, looking for weaknesses before the real-world attackers can find them.
It's a paradigm shift. Instead of just letting a powerful AI think its way to a solution and hoping it makes things up, this paper shows that the path forward is to combine the AI's creative reasoning with a rigid, symbolic system that keeps it honest and grounded in reality.
It's a perfect partnership between the creative, probabilistic power of a neural network and the deterministic, logical power of a symbolic system. It seems that for AI to be truly reliable, it needs a good, strict manager.
A fascinating look at giving a super intelligent AI a very firm rulebook and watching it win. That's all for today's Daily Papers.